Hmm. We're back. Hey, Antifral. I got disconnected from Restream.io. And I don't know why. I just got a connection loss. Sorry, guys. Really sorry about that. I don't know. Hello again, Sergio. I don't know what happened there. I just got the disconnect message here from Restream. Oh, that's annoying. That is annoying. So let's just give away one nano here. Hello, guys. Sorry about that. So, 1 nano for pies. Sorry. 1 nano for you. Nardo E says all good, yeah. So technical difficulties here. I'm getting a new Wi-Fi router next week. And I am with more bandwidth. So, welcome back. So maybe this helps. Okay, all you guys are back again. So I don't know what happened. I got disconnected from Restream.io. Hey Colin, welcome back. Sorry, guys. Andefnau says, by the way, first 2 minutes while counting was on was muted by Twitch because of it appears to contain copyrighted content. Really? Copyrighted content. I play this thing here on YouTube and it says jazz music, royalty-free background, Creative Commons music. So I was hoping that this title actually is correct. Oh, you don't see it. So I'm playing this thing. So I was hoping that this was actually royalty free. Oh. Thunderflower says Twitch sucks sometimes with this. Yeah. Do they flag copyright stuff incorrectly? Do you think? Colin says, be honest, Gustav, your background is stock images. Which background? Like my background here? Which background do you mean? Yeah, it's stock images. I live in the basement, like every good coder. Okay, so now I totally lost the plot. I don't know where I stopped. But it's nice that you're back again. So if any one of you wants to participate in the giveaway... Oh, I have to restart the giveaway timer. If you want to participate in the giveaway, just post your Nano address in chat. Or if you are in my address book already, just write something in chat. Just say hi in chat. That's enough. Okay, 9 minutes, 50 seconds for the next Nano giveaway. Did you click the send button? By the way, I don't know who won. Who won? Pice won. And I think, let's check. I think I clicked send. No, the last send was... Oh. Did I not click send? The last giveaway was 2126. Now we have 41. I think I did not click the send button. Let me send. Yeah. No, I didn't. Let's resend it then. One nano. Okay, now it's out. Okie dokie. So yeah, so where was I? Yeah, okay, the message deserializer. Okay, I was thinking if we could use our async version of it in channel in proc. And yeah, so for that we need an async runtime to call the read function. Sorry, the read function. And do we have an async runtime? We do. We do have the async runtime. So that's good. So here we could say self.async runtime spawn. No, how to run. What is async runtime? Oh, it's a weak pointer. It's a weak pointer, so we have to upgrade it. So for the runtime, we have to upgrade the weak pointer. And then we can move that into this ifs clause. And then we could say runtime dots. We have to unwrap here. No, we don't have to unwrap. What is runtime? Arc async runtime. Okay. And what can we do with the runtime here? We can call post. Oh, there's field Tokyo. So Tokyo, here we are, dot spawn. So here we can spawn an async task. Like that. And in there we could... Let's move that down. So in this async task down here, we could call our new read function, which does this deserialization in an async style. Hey Newsh, welcome back to chat. Let me just add you to the spinner wheel. Oh, I mistyped your name. Can I? Because you are in my address book, if I remember correctly. You are. All right. Okay, Tokyo spawn. So we have to take... So I want to comment this part out, because this is the old implementation. And then I want to use the new async message deserializer. And arguments are incorrect. Yeah, because we don't take a buffer read function here, but we take an implementation of the buffer reader trait. So we have to pass the buffer reader here. And we don't have a buffer reader right now. But we can create one. And then in the async block here, we have to say async move. So that the message deserializer is moved. And here we call read. Yeah, so read. So read now returns a result. What does it return? What is result? Result is an result option boxed in message or parse status. So we call read. And then we have to call our... So this still uses callbacks. But that's okay. We go one by one. So here we have to call the callback message callback. But we have to call this callback from the blocking thread pool, because we don't want to block our async thread pool. So we say spawn blocking. What does spawn blocking take? and FN once. So we say spawn blocking and spawn blocking. Oops. Spawn blocking calls our callback. Callback is error code or option boxed in message. Callback message is the name. Let's say callback message. Callback message. What error code option? And result is result option parse status. How can I make... I have to convert the parse status into an error code? Oh, look at that. So this is the old way. This is the old way. What does this one do? Callback, error code new. Callback message. Offset. Callback, error code new size. So we have to take this result here and we have to say maybe match result. And if it is an error, we call callback message. Does the error code matter? I don't think so. Maybe just fault, not supported fault, and none. And if the result is okay, we get a message. Option boxed in message. And here we call the callback with error code new, which is okay, and message. Is that right? Chat, what do you think? Is this correct? Luckily, we have a lot of tests. And if there is something wrong, the test will show us. One Nano 4. Sergio, congratulations. Okay. Congrats, yeah. Oh, restart. All right. I think this is okay. And also this in proc channel says rigged. I told you so. It is rigged. It is rigged in a very complicated way, but it is rigged. So this in proc channel is only used in tests, so that we don't have to make real network connections. And it is actually used in one place in the production code where we want to send a message to ourselves, which just can't fail. So there are no network errors when we send a message to ourselves. So we don't have to be very careful with error handling here. So I think this is okay to just say error code fault. And here we just say, yeah, it's okay. I think this is all right. Now, the only thing missing is our buffer reader. We have to implement a buffer reader here. And I think... So basically this part here. So this code created our old callback style. Our callback for reading some bytes. And we have to convert these lines into an async implementation of buffer reader. So how does it do that? It has an offset, atomic usize offset. So this is the buffer. And here we have the buffer as a byte slice. It copies that buffer and it creates that callback. So we have to just push that buffer here. We just have to push that buffer into a struct that we call... we need a struct, and how do we call that? Vec buffer reader. Johnny says had to leave the chat. So you're back or are you leaving? So we need a back buffer reader which internally has the buffer, which is a back U8. And this buffer reader should then implement buffer reader. Oh, what are these live types? Are they in the VEC? In the trait? No, they are not. Can we remove them? Ooh. Oh no, I know why they're. Ooh, I know why they're there. I forgot to put async trait above. Impl buffer reader for vec buffer reader. So here we have to say async trait. Cannot find attribute async trait. Import async trait. So now let's implement that trait. No code actions available. What? Okay, let's copy it by hand. Like that. All right, so that's okay now. Johnny says, leaving, you can remove me from the Wheel of Fortune. No, I won't. You can stay on there. All right, Johnny, have a good evening. Have a good night. All right, so this is our vec buffer reader. And I want to do this test-driven. I want to write some tests for the vec buffer reader. So test, not test. So in Rust, you write the tests in the same file as the code, but that's a production code, which I really like because then I just have everything in one place. And if also says the names are there forever. I mean, until the stream ends. Yeah, I see it the same way. So let's write a test for our vec buffer reader. Oh, this is an async test, so we have to say toke test. Expected item after attributes. Ooh, okay, so fn, async fn. So what do we want to test? Let's start very simple. Empty vec. So we say var. Let reader is back buffer reader new. Oh, it doesn't have a new function even, so let's create a new function. Let's create a new function there, which takes the buffer. And we say back new, so an empty back. And when we say reader.read, so now we need a buffer. No, what does the reader take? Arc. Oh, okay, so let me also put that on the to-do list, because that's also bad. So right now it takes an arc mutex back u8, and we have to change that so that buffer reader should take, I don't know, a byte slice or whatever. Let's say byte slice. Like that, instead of arc mutex vacuate. So yeah, another thing to refactor soon, because arc mutex. So this arc mutex was needed when I ported it from C++ to Rust. But now that most of the code is in Rust, I think we can remove the arc and the mutex and the vec, and we can just use a byte slice. Much simpler. Okay. So but for now we have to actually use that. So buffer is an arc new, mutex new, vec. Let's just create a vec with 3 bytes. And then we call read. And we want to read 1 byte into our buffer. And we expect this to fail. So assert equal. I'm just asserting that it is error. So let's run those tests. Or should I do it in a split screen maybe? Do we have enough space here? Oops. Like that. Rust and node and run. No, I want to watch. I want to continuously run the tests. Maybe not enough space, huh? So like that. And it fails. Another giveaway. One nano for end of null. End of null. 1 nano for you. Yeah, sent. Thanks. Sure. There you go. And let's go back to... LFLF says, the game is rigged again. Yeah, it is rigged. Okay, it can't compile because buffer reader isn't found. That's right, we don't have the buffer reader, so maybe I just create our new fact buffer reader here. Let buffer reader is fact buffer reader new. And can I give it the buffer? What's the buffer? Buffer to vec. Yeah, let's just, like the code up there does it, let's just say buffer to vec. And it still complains because store this in the heap by calling box new. Oh yeah, this has to be a box. And what's wrong in that down there? Future cannot be sent between threads safely. Captured value is not sent. Which captured value is not sent? The message deserializer? What does it say? Future is not sent. Which is not sent. Self read buffer lock unwrap. There's mutex guard, which is not sent. Line 326. Line 326. Oh, that's in the test. What is wrong here? Oh, I forgot to restart the timer. Thanks, Jean. I forgot to restart the timer. Sorry, guys. Oh, so arc async message deserializer is not sent. Async message deserializer is not sent. Send is not implemented for buffer reader. Oh, the buffer reader has to be sent. Okay. So the buffer reader has to be sent. Maybe we can just declare that in the definition of the trait. Buffer reader has to be sent. Yeah, let's just say buffer reader has to be sent. And still a problem. Where do this? Which is the first? Let me just rerun that. I don't know which one was the first error message. So this is the first error message. Future cannot be sent between threads safely. Future created by async block is not sent. But why? The trait sync is not implemented. Oh, it has to be sync also. Really? But why? I don't understand why. It has to be sync? But do we access the buffer reader at the same time as... That doesn't make sense. We don't. Why? So send is okay because Tokyo has a work stealing scheduler, and it can move your tasks from thread to thread. So send is okay, but why does it have to be sync? That doesn't make sense to me. Future cannot be sent between threads safely. Async block is not sent. Future is not sent as this value is used across an await. So which value is used? Send is not implemented for mutex guard. Mutex guard. Line 238. 238. Oh, which file? Am I at the wrong place? Oh, sorry. What? Buffers data dropped here. And 326 in message. Deserializer 326. 326. Read buffer lock and ref. Where are we here? Oh, this is the V2? I think I know what's up, guys. Yeah, so this still has the... No, it still has the read buffer. It has the read buffer. Yeah, that's right. Oh, because it is in a mutex. I think we have to remove the arc mutex here. Because we cannot use a mutex guard after an await. Mm-hmm. We can't do that. Can't use a mutex after an await because the mutex, the lock guard, the mutex guard is not send and sync. What to do? What to do here? Shift header. Shift header read. Buffer reader read. What to do? What to do? What to do? Can we change that into just an array? And then we don't use a lock mutex guard over an await because here. Here's the await. Where's the place where it's a problem? So here we have the buffer. So this is the mutex guard. And where's the await happening? Buffer reader. Where's the place? Where is the place? Future created by is not send. The trade send is not implemented for mutex guard. In line 359 in message Deserializer. So 359. Future is not sent as this value is used across an await. Which value? Chat, do you have an idea? Do you have an idea, chat? I'm a bit lost right now. Okay, I don't want to bore you, chat, with this. So, what do you think of the following? LFLF says the result of the read method is not sent, right? Yeah. So it says that this future here, yeah, this is in the read, this is in the channel in proc, that this future is not sent. And that just doesn't make any sense to me. Why is that future not? Yeah, because the read future is not sent. Yeah, because the read future is not sent. But why is the read future not sent from message Deserializer? Oh. Why is the read future not sent? Hey, Pies, congratulations! Let's have a look again at the read future from... Let's have a look at the read future. Where is the read? This is the read. This creates the read future. It says buffer reader.read, and here we clone the read buffer. The read buffer is an argmutex, so that's okay. And maybe the received header is the problem. What's going on in the received header? So here we create... So here we create the mutex guard. But I don't think there are... So this... Oh, this is an async function. Okay, so where do we have an await here in somewhere? Await? Down there. But we dropped the buffer. So we drop the buffer here so that we don't use the buffer after an await. So this should be safe. That just doesn't make sense. Okay, chat. I don't want to bore you with this. I don't know what's wrong here. Oh, Colin says the mutex guard is suspicious to me. The mutex guard, you mean this mutex guard that we have in the receive header? Because only here, let's see where we lock the read buffer. Let's search for all of the usages. Oh no, not all the usages of lock, but oh, that I did not want to find all of those usages. Let's find all usages of read buffer. So here we have the field. Here we have the new function where we initialize the field. This is Deserialize, which acquires the buffer lock. But this is not an async function, is it? No, this is not an async function. Yeah. And then we have the read function, which it's complaining about. But this does not acquire the lock. Then we have the receive header function, which acquires the lock here. But then it drops here. It drops the mutex guard. It drops the mutex guard here. Very strange. And the last usage is down here. I don't understand. Colin says, in C++, mutex locks can't be copied. Maybe that means they can't be put into a future, not sure. Yeah, so the problem is with await. So when we call await, so like, let's say we do something here. So here we acquire the mutex, and when we say do something, dot await. So and then later we would use the buffer after do something else with the buffer here. So this can't work because when we call await, we return. So we create a state machine, or Rust does this for us. It creates a state machine and it returns. It returns the future here, and it goes back into the Tokyo runtime. And at some later point, we re-enter this function, and it goes on. And we can't return here and re-enter with a mutex guard open, because the mutex guard is not send and not sync. It can't be, so we can't send it to another thread. And that's why we can't pick up a mutex guard after an await, because the Tokyo runtime, it could do whatever. It could move our task to another thread. We don't know what Tokyo does with our task, so we can't use a mutex guard after an await. And that was my suspicion, that somewhere we use a mutex guard after an await, but I couldn't see any usages here. So maybe the problem is something else. And I don't want to bore you, chat, with finding that issue. So my suggestion is that I create a branch here, and I'll have a look. I'm going to fix this issue off stream, and maybe we work on something else. What do you guys think? I think I want to do that. So let's create a new branch here, and I call this work in progress async in prog channel, and I just push all of the we don't have many changes, do we? Not much really. Yeah, so let's move that there. Yeah, let's just say work in progress async in prog channel. And then let's go back to, let's push that to my GitHub. Underflower says, let's go to the message plus payload enums. Oh yeah, that would be interesting. Sergio says, great to see you, Colin. So let's go back to develop. And okay, so we are back here. So yeah, under null says message plus payload refactoring. Oh, we have the test running. So let's close that. Okay. Message and payload refactoring. I want to see if we can do this right now. So this is the C++ code, and we have calls. So message header is okay. It has serialize to serialize, and it has, here's the message class, and here is serialize. And oh, the countout isn't running again. Oh, why am I forgetting this? How late is it? Yeah, so we have roughly half an hour. How many nanos do we still have? 4. Yeah, then I just give away 2 nanos at the end. Deserialize and visit. So I'm just want to make sure that we do not have C++ dependencies, because then refactoring becomes really hard, because then I have to refactor the Rust part and the C++ part at the same time, and this is something I'd like to avoid. And it was, you wanted to go to bed earlier, didn't you? Oh, I always want to go to bed early. Yeah, got me. You got me. But I'm not. I'm going to work until 11 German time. Serialize, deserialize. Because we don't have much time left until now, so I want to also have a look at the dependencies off stream, because this also can take some time. I think something safe we can do is this refactor that we talked about earlier, where we split up the message deserializer into an application and a logic part. Because this is pretty safe, because we don't have any dependencies that we need to think about for this refactor. So I want to do that one. So that one where we split the message deserializer class into 3 parts and extract this part, which is pure logic, which just takes bytes, a byte slice. And we only have to do one hard thing here, and the hard thing is find a name. Because here I named it message deserializer, but we already have a class called message deserializer, which uses callbacks. So what do you guys think of renaming our current message deserializer into callback message deserializer? So that the name message deserializer is free and we can use it. Let's go to message deserializer. So that is the async. Oh, this is still... Yeah, let me do the renaming again. This won't cause conflicts, I hope. So let's rename that again to async message deserializer. And the old message deserializer that uses callbacks. The old message deserializer that uses callbacks. Where is it? Must be down here. Here it is. Artificial is naming things the hardest part. It is. I find naming things incredibly difficult. Incredibly difficult. So this here uses callbacks, the read-up query callback. for deserializing a message, and it also has these things here: block unique, or vote unique, or publish filter. Not a fan here of that. How could we rename that? So we can either rename this struct, or we can find another name for the logic part for message deserializer. We could also name this message deserializer logic. Oh, not a nice name, is it? Chat, I need your help. I need your help with naming it. So this is just the logic implementation. It just takes a byte slice and it returns a message. So we could name this message deserializer logic. We could call it So in the end, I think when we are done with all of that, Anufna says logic message deserializer sounds like a German word to me. Seriously can't help here. Oh, please help me. Come on, guys. Colin says message deserialize impl. Yeah, impl. Impl. Yeah, let's go with that. And we can, so renaming is so easy with the plugins. I can rename it anytime, so it really doesn't matter which name we choose, as long as we improve the naming as we go along. So yeah, let's name it Impul for now. Why not? So let's create. I want to put it here so that I don't have to scroll so much. So let's create a struct. Message deserializer impl. And this is the logic part of message deserialization. Philip says, Colin, you stole my idea. Okay, so if two guys have the same idea, then it is in favor of that idea. So, and now we have to move. Now we have to move some stuff into our logic part. First, let's create an instance of this logic in here. So let's impl. So let's say deserializer impl is message deserializer impl. And we have to give it a value here in the constructor in a new function. Like that. It doesn't have any state. I think it's a stateless. Is it a stateless? I think it's a stateless struct. We don't even need a struct really. We could do this with just functions. We don't need a struct really. It doesn't have state. Does it have state? It just takes a byte slice and it calls other deserialized functions. We don't need a struct. Should we, chat, what do you think? Should we do this without a struct and maybe with just a function? I think we should. What? So the next question, chat, is how should the function be named? Deserialize message. Do we have a function like that already? So what's the signature of our function? It should take the header. And it should take the payload bytes as a byte slice. And it should return... What do we return? Option boxed in message. Parse status is the error type here, I think. So I think it should return a result, and when it succeeds, it should return a box, the message, and if it fails, it should return the parse status, because we use the parse status currently as an error type. And let's just call, okay, error here, our status. I don't know, none, whatever. All right, let's spin the wheel. On Nano for Wenderson. Nano is the light. Wenderson. Nano is the light. Congrats, yeah. So, deserialize message. I think this is okay. It's just a function. I hope this is not a naming conflict. Let's run a cargo check. But I don't think we have a deserialize message name function. Who are these errors again? What is that? Message deserializer impl. Oh yeah, we have to remove the message deserializer impl field, because now it's just a function. Oh, I thought we did. No, here it's still there. So let's cargo check again. Strange with these errors. Looks good. So now let's see if we can move our deserialization code into this deserialize message function. So which one would that be? I think this. I think payload size. I think this one here. Yeah, this is the deserialize. So this looks mostly how we want to have it. So it is called deserialize. It takes a header and a payload size, but we don't take a payload size. We take the byte slice directly, and it returns an option boxed in message. An option. It doesn't even return a parse status. So this here does the reader. So these two lines, the first two lines, they read from the TCP stream, and then all of the lines after that, do the message deserialization. So I want to copy these lines up there. Copy them. So again, I'm duplicating code with the goal of deleting the original code as soon as this works. So stream adapter is something I wrote. We don't have to worry about this. Something that I can delete maybe. Oops. So this stream adapter just takes a byte slice, and the byte slice is our payload bytes. And Deserialize, keep alive. Okay, so this now calls all of the other deserialize functions, and we have to move all of them. We have to move all of them out of the message deserializer. And this, there's some specialty here, and this is the publish filter. So Bitcoin is not producing blocks. I have to automate this somehow. 10 minutes. You know, guys, let's speed this up. Let's stop this. Let's say 5 minutes. Does it work? Yeah, 5 minutes. No, it's okay. Like, please help me out. Like, I forget this so easily. Yeah, the publish filter. So the publish filter does, I think it creates a hash or something of the byte buffer. And if this publish message was seen before, we set the status to duplicate message, publish message. So that means we... That means we have to use a struct because we have to have the publish filter. Yeah, okay. Oh, I wanted to use a function because functions are simpler, but let's use a struct with a publish filter then. That's okay. Where was it? So back to our impl name. So impl, it has to use the publish filter. So can I just copy that from down there? Publish filter. And let's create a new function for that. And then the deserialize message has to move inside of our new struct. Like that. And it takes self now, self. And then it returns. Yeah, now we can move all of those deserialize calls into our new struct. So all of them, deserialize, keep alive, publish. All of them, we can copy all of them. And move them into our new impl. And now let's see what errors we got. Wenderson says, I'm back. As always, you're doing a great job. Thanks. Thanks, Wenderson. And you even won a Nano, I think. So we have a couple of errors here. Yeah, so this set status, I don't want to use the set status. I want to return the status. So here we say error, and the error is the parse status, duplicate, publish message. And now we have to adjust all. I lost track here. When it says, thank you, Nano is the light. Yeah, Nano is the light. So all of those small functions, they all say self dot set status because that's how the old code worked. It had a status field with the status, but I don't like that at all. I want to return the status. So it should not return an option boxed in message. It should return a result boxed in message parse status. So this would return okay. And this would return error. What error is this? No one knows. Invalid. Okay. So the next one, oh, we have to do this for all of them. And also just moving stuff into a box. Yeah, okay, I don't want to do too many things at once. Let's just get rid of the compiler errors and then let's refactor that code and make it nicer. Because there's a lot of code duplication going on that we can remove. Hey, Bob, congratulations for 1 nano. And now I'm restarting it, or immediately. But not with 5 minutes. But with 10 again. 10 minutes. Start. Yeah, so Bob, let's send you your nano. Okay, so this also has to return an result. Our status. So we have to do this for all of them here. Result. Our status. Deserializer result. Our status. And this is okay. And this is error. Hey, Etern Viking, how are you? If you are quick, you can post your nano address and take a part in the last giveaway. I think we have 1 or 2 nanos left. How many do we have left? 2 nanos. We have 2 nanos left. So error. And okay. Result parse status. Yeah, a lot of code duplication. Those functions, they all look the same. I think we can really shrink this code once we are done. Result parse status for that one. And then we can write some unit tests for that. Okay, and error. Oops. Error. And okay. A bit boring, but that's also part of the job. We're almost there, guys. Almost there. Result. Status. And this is result. Our status. And this is okay. How many are there of these functions? Oh, that name I don't know how to pronounce. What is the language of programming? This is Rust. So we are porting the Nano cryptocurrency node from C++ to Rust. And the project is called RS Nano. here, rsnano.com. You can find all of the information there. Vote uniquer. Okay, so we still have to add the vote uniquer. Result. And I'm a bit skeptical that these block uniquers and vote uniquers are worth it. I want to run some tests and see if maybe not having them would not impact performance a lot. And then I would love to remove them. But I'm not sure about that, so I have to run some tests there. So this is return error. And this is okay. So block uniquer, network constants. Okay, we have to add all of those fields. That's okay. Underfloor says Vlad Bogdan is the name. Oh, you can read that? Cool. So what is that? Oh, what is that? Oh no, this is insufficient work. Insufficient work is the error here. And this is okay. Underfloor says I think I can. That's cool. Result. Our status. Oh, and the last one, finally. That was a bit of boring work here. Result. Our status. Okay, and error. Oh. Yep. So the last one, invalid and not a type. Should return error with this. Our status here. And what is that? So here buffer payload size, that is also not required. The payload bytes is already the correct length, so we don't have to take a slice from it. So it's just payload bytes. So Vlad asks, have you learned Solidity? Solidity? No, I haven't. Okay, so we need to add some more fields here. So we have the publish filter, but we also need to add all of the other fields. So we have to add the block uniquer, the vote uniquer, and network constants. So let's add them. Then let's recreate the new function so that we have all of these dependencies in there. And now let's check for errors. Just one. Oh yeah, this should return okay. No errors. Chat, we don't have any errors. So that went smoothly. It's still, the code is still not in a good form because there's a lot of duplication. Especially this moving the message into a box happens in every function here. So we can move that out into just one place. But before I make this nice, I want to use this new class. It's not a class, it's a struct. So I want to use this new struct. I want to use the message deserializer impl. And I want to use it in our old message deserializer. So let's use that here. And let's yeah, let's initialize it here. Underfloor says, one small step at a time. Yeah, that's the way I like to work. One stream per week. Oh, and Nano is the light. And we're going to reach our goal. We are going to have a full running Rust node. Maybe even next year. So I'm very hopeful that next year is the year of a full running Rust node. So message deserializer impl. No, I wanted to call the new function. New. And what does it take? It takes, oops, it takes the network constants. Oh, they were removed. I have to clone them for now. This clone can be removed later. What's next? The one is the publish filter. Oh, they are all moved. Now let's clone it here then. Because I think we can. This is just temporary because all of those fields will be deleted in the next few minutes. So network constants. Let's also clone them. Oh. Like that, and both unique. Like that. Oh, like that. So network constants, the next one is publish filter. Publish filter, the next one is block uniquer. And then we have the vote uniquer. And that's it. Publish filter. How many more nanos? 2 nanos. And if null, the game is rigged. 1 more nano for you. So we have 7 more minutes, so I don't restart the timer now. Let's close that one because I'm going to give away the last nano when we stop the stream, which is in 10 minutes. Publish filter. What's wrong with publish filter? Oh, it's called network filter here. Network filter. No more errors. So now let's use our deserializer impl. Let's use it here. So we have the buffer. We read into the buffer. What is buffer? A mutex guard vacu8. So now let's call self dot. Vlad says, I think English isn't single language. No, it's not my native language. I'm German. Buffer. So now let's call deserializer impl. And let's call, what is the function? What was the function? Deserialize message is the name, right? Deserialize message. Yeah. And we have to pass the header and the payload bytes. And the payload bytes is this thing down here. And then this returns. So let's remove all of that. So this returns a result. So the result is either a message or an error with a status. So if it is an error with a status, we have to say set status, and we have to return none. On like that. Oh, that says, but I like the way you pronounce my name. How is it pronounced? I have no idea. Am I saying it wrong? And so, and if it is a message, we have to say set status. parse status. Oh, what is it? Okay. What is there? Success. And we have to return some message. And that's it. Guys, that's it. So now this is the part of the logic. So let me just delete these functions now because I think they are not being used anymore. Yeah, so we can delete all of those deserialize functions. All of that. Let's delete all of that. Yeah, look at that, chat. I think do we have errors here? No more errors there. So now the message deserializer shrank. Are these fields still in use? Here's the assignment. Oh, there's still some checks. Okay, we have to. This is also logic. So these checks I want to also, but not today. The stream is over. So these checks should also go into a logic part. So we still need the network constants, but the publish filter. We don't need the publish filter, block uniquer. So I think we can just block vote uniquer. Let's remove them. Okay. Everything's good. Okay, we got it, chat. So that's a good ending. That's a good ending for the stream. So now we have the message deserializer. Let's have a look at it. There's still work to do here. But that's it. So up until this is the end. Down there. So now it calls into our logic part. And the logic part is up here. And the logic part, this is the logic part. The logic part is free from infrastructure, and we can write unit tests for that very easily. And maybe we work on this on stream and make this nicer, refactor it even more, make the code smaller, or maybe not. Depends on what you guys want to see. But this is now a good place to run the tests and create a commit. So let's do that. Let's reformat the code first, and let's trigger a build. Oh, let's build everything, and then let's run the core tests. Okay, and while this runs, let's go back to the chat. Anifnal says, just a quick question. Does Nano accounts have something like public account alias? Like a human readable not address? As far as I'm concerned, it does not. Still asking though. Oh, the Nano 2 guy developed that. So you can register. So it's a centralized service. It's a centralized service, but it's really useful. So I have a Nano.2 address. It's where is it? Up here in the corner. Nano.2/Gustav, and you can just register your. So the name of the guy who wrote it is Esteban. He has a couple of cool Nano services. Really useful. And if says looks readable for Rust. Yeah, but it's not on a protocol level, right? No, it's not on a protocol level. Yeah, but I think with QR codes and with yeah, this is basically a problem that all cryptocurrencies have because of those long addresses. How do others solve it? Is there decentralized versions of that? I don't know. And if not, says, yeah, he's cool. Yeah. Okay, so the tests So the tests, I'm going to let the tests run, and if everything is green, I'm committing that. So that's for today. A bit chaotic again. So my plan is to work off stream on. Oh, we still have 2 nanos, so let's just spin the wheel now. So my plan is to work off stream on finding out why the async refactoring that we tried didn't compile. 1 nano for pies. Congratulations. And then we can continue. And let's spin it one more time. And then we can continue next Tuesday on, yeah, whatever you guys want to see. I'm not, again, so the game is rigged. The game is rigged. The wheel is rigged. So that's it for today, guys. It was fun as always. See you in a week. Have a good night and have a good week. And always remember what Windows says, Nano is the light. See you next week, guys. Bye-bye.